Let's recall areas of some of the basic shapes that you need to learn in the school and the college. So we have triangles and rectangles, squares. Square is a special case of rectangle, and then circles and ellipse. Ellipse is again a special case of a circle. So let's look at one by one. So let's look at triangle. Triangle means a shape which has like three sides. So let's look at this triangle. And what we need to know to find the area is what we call the base length. That's the base. So we normally use the B for that. So easy to remember. And then also we need to know the height. So what we do, height is the perpendicular you drop from one of the vertex to the base. So let's say this height is h. So then the area formula is A equal half BH. So you multiply the base and the height and take the half of it. So that is the formula for the area of a triangle. So interestingly, this same formula works for two other special cases. So let's look at them. For example, this case. In this case, what happened? Two sides are perpendicular to each other. So base is here like before, but the height simply becomes the other side. So that means we can still use the same formula. So half BH. And the other case is this. So what happened in this case is you can see one of the vertex is out. So what we do in this case is, let's say as before, this is the B, the base length. What we do, we extend this base out like that, and then we drop the perpendicular on top of that line. So we do this, and then so this is perpendicular. So we're going to consider this as h. So the h is this now, because what is that? It is always the length of the perpendicular on the base. Should be on the base. So now we can use the exact same formula for this case also. Those are the three cases that you can encounter, and the same formula works for all three cases. So let's look at the next one, the rectangle. So rectangle is the easiest one actually. So what happened here is you can see these are 90 degrees. So that's one of the property of a rectangle. So what we have is the base. So that's the B, and then the height. So to get the area, what we simply do is we're going to multiply the base and the height. So it's very easy. So the base times height. So that is the formula for the area of a rectangle. The same formula works even the rectangle is little slanted, then you can call it rectangle. It's become parallelogram. So like a situation like this. So let's say we have something like this. So as before, what we can do, we can extend the base and then drop the perpendicular. So we extend the base and drop the perpendicular. So the base here is the B. That's the base. The base stops there, and then the height is this, and then you can still use the same formula to find the area of this one as well. But remember how you get the h. H has to be the perpendicular distance. Okay, so let's look at the next one. So next one is a square, and then you can see square is a special case of a rectangle. So that means we can use the same formula from the rectangle, but we can actually simplify this a little bit. So for example, this is 90 degree, and then we normally use A for squares mostly. So all sides are the same. So using the same rectangle formula, as you can see, A has to be B times H, but they are the same. So you get A squared. So that is the formula for the area of a square. When a square is slanted, we get what we call rhombus. So all three sides are the same. So let's say A as before. So A and A. So what we do as before, we can just extend this one, and then we can use this formula from the rectangles to find this one. So but you have to find the H here. So that we don't know. Because this is not unique, because depending on the angle, this can be different. But we can use the same formula from the rectangles version to find the area. But there are like different formulas for this one, but you can find those formulas in the main video about areas. So let's look at the next one. Next one is the circle. So when you have a circle, we need only one information. We need a radius. So if you say r is the radius, and then we can write the formula. It is a equal pi r squared. So that's the formula for the area of a circle. And then we have a special case of the circle we call ellipse. So when you have an ellipse, now what we can look as the radius. So what we can do is we can look at these two sides. So we're gonna say we normally call this side is A and this one is B. And then what happens? So A and B. So A is this length and B is that length. So these two actually act as the radius in a circle formula. So that means um, the area of a circle or area of an ellipse you can write as pi AB. So that's the formula for the area of an ellipse. So these are the basic shapes that you need to learn in school and the college. Thank you.